Here we go. 5.4 medians and altitudes. Okay, so these are a little bit different than what we are accustomed to. Altitudes, you'll recognize that as the height of the triangle, so that's not too difficult. Medians is not too difficult, but it is a new thing for most of us. So how do I use medians and altitudes of triangles? So what is this median about? I should have highlighted that thing, but I forgot to. A median goes from vertex to midpoint. Vertex to midpoint. That is a median. Now let's compare that with mid-segment. Remember, mid-segment went midpoint to midpoint. Here is your in 5.1, here's your mid-segment going midpoint to midpoint. A median, though, goes vertex to midpoint. Okay, so a median is a different monster. And just like our perpendicular bisector and our angle bisector within a triangle, those are concurrent. Remember that word, concurrent? Where they all three of them cross at one point. Same thing with a median. And so a median's from this one vertex comes across here and goes to the midpoint. This other one goes from the vertex across to the midpoint, and vertex across to the midpoint, and all three of those medians intersect at one particular point, and we call that point the centroid. Kind of a cool name. I have no idea where that name came from, but I like saying it. Centroid. And the centroid is pretty cool because let me see how they see it here. The medians of a triangle intersect at a point that is 2/3 of the distance from each vertex to the midpoint of the opposite side. So let's put our focus on this 2/3. So here is your centroid, the point of concurrence of these medians, and the distance from the vertex to the centroid will always be 2/3 of the entire length. So vertex to centroid is 2/3 of the entire length, and so therefore, of course, midpoint to centroid is going to be 1/3. That's helpful. And what's also cool, and it doesn't say it in here, does it? No. So let's make sure to put it in your notes that the centroid, if this triangle is created out, it's a separate entity, and it's created out of a constant thickness and a constant density material, then this centroid will be the center of gravity, which is pretty cool. If you, like for example, had a big old sheet of cardboard and you make any kind of triangle, does not matter what kind of triangle, any kind of triangle, and then you find the centroid by creating these medians going vertex to midpoint, then that centroid, you could hold up that triangle at that centroid, and the entire triangle would balance on that centroid. That's what it means to be the center of gravity. So let's use some examples, do some examples here of using this centroid and knowing that the distance from the vertex to the centroid is 2/3 of the entire length of that median. Here we are given triangle RST, okay, this larger triangle on the outside here. Q is the centroid, so when they say centroid, we're thinking medians, and medians go from vertex to midpoint, and they're telling us that SQ equals 8, so from S to Q equals 8, and they want us to find QW, this length here. They also want us to find SW, the entire length of the median. Now let me just mention that yes, we have this length here, the 2/3, and we can find the 1/3. We can also find then the whole thing, but that's all that we can find with the information we have here. It does not tell us anything about these other medians and sides and so forth. Okay, so knowing the 2/3 is 8, we can set up this equation and say SQ is equal to 2/3 of the entire length. So there's different ways of doing it, but here's one way to do it. So SQ is equal to 2/3 of the entire length. So SQ equals 2/3 times SW. Now we know what SQ is. We know that's 8, so we can substitute 8 in for that. Now how would you solve this equation? And the easiest way to do that is to multiply by the reciprocal. To move the 2/3 over to the left-hand side, multiply by the reciprocal of 2/3, which is 3/2. And when you do that, 3/2, notice you have 3 divided by 3. So these 3's cancel out, and also 2 divided by 2, and the 2's cancel out, and we're left with just SW. And then of course you put a 1 underneath the 8, and multiply across the top. 3 times 8 is 24, and 2 times 1 is 2, so 24 divided by 2 is 12. So this entire length here is 12. Another way of thinking about that is that what I would do is put the 2/3 between the vertex and the centroid, and then 1/3 over here. So now you're thinking, okay, whatever this 1/3 is, I need to multiply it times 2 to get the 2/3. So in other words, I take this 2/3 thing here and divide it by 2. So what is half of 8? And it is 4. Okay, so does that make sense? This guy is 4. That's 1/3, and then the remainder is 2/3. 2 times is 4, which is 8. Yep, that makes sense. And then they also want us to find the entire length there. So then 8 plus 4 gives me 12. And the way they did this here, they said that QW, this 1/3 part, is equal to the entire length minus the 2/3 part. Okay, you can say that. And then we're trying to find the QW. Are we? I guess so. Okay, that's fine. Oh, we just found it already here ourselves. Okay, I got it. But then, so there's a way to do it mathematically also. All right? I like my way better. Okay, here's another example. Let's zip through this. This is using coordinates plane, and we're given these coordinates for this triangle, and they want us to find. What do they want us to find? They want us to find the coordinates of the centroid. And so remember, the centroid is created by medians. Medians go from vertex to midpoint. So let's first find the midpoint of this side. We could have found the midpoint of one of the other sides, but our guess is, at least that's what their guess is, and I like it, is that this is going to be line up on this vertical line, which makes things a lot easier. So we find the midpoint. Remember, when you want to find the midpoint of a side or of a segment, you take the average. So 2 plus 6, here's 2 plus 6 is 8 divided by 2 gives us 4. And then do the y-coordinates. So 5 plus 1 is 6 divided by 2 gives us 3. So the coordinates for the midpoint are down here. And then the entire length here is 1, 2, 3, 4, 5, 6. So the entire length is 6. Remember, from the vertex to the centroid is 2/3, and the remainder is 1/3. So if I have the entire thing as 6, and this is 2/3 and this is 1/3, then how much is each block going to be worth is the question, and the answer is 2. Is that going to work? Yeah, that'll work. So this is going to be 2. In fact, I can just, well, that's right. I don't, they give us this centroid later. That's what we need to find. But taking this 6 and dividing it by 3. I want to break it into thirds, and so each third is going to be worth 2. So I go 2 blocks up from here. I'm starting at 3, going 2 blocks up will give me up to 5. Okay, so there is our centroid calculated on the coordinate plot. Now it is your turn, your time, yeah, your time also, but your turn. And there are 3 paths that go through this triangular park. Here's your triangular park. We're going from vertex, and they tell us this is the midpoint of the side. So each of these is, oops, you can't see it. Each of these is the midpoint of the opposite side. And they're saying, okay, what if SC, what if this entire length here was 2,100 feet? Then find PS. So PS is going to be 1/3. So what I would do is put 1/3 here and then 2/3 there. And so to find PS, you're going to multiply 1/3 times the entire length. And then to find PC, you multiply 2/3 times the entire length. Okay? And then here with BT is 1,000 feet. So this guy's 1,000 feet, and they want us to find TC. So do we do this 2/3, 1/3 thing? Is that what we do on the side here? No, wait a second. Remember, this is a median, goes from vertex to the midpoint. So this guy is the midpoint. Don't forget that, man. Midpoint. Do I have space to spell that? So this guy's midpoint here. So therefore, if this guy up on top is 1,000 feet, what do you think this other one's going to be down here? And then what is the total going to be? I'll let you do this last one on your own. Go ahead and pause the video and do that if you would. And now altitude. Altitude, like I said, is the height of the triangle. So when you see altitude, think of height. And what I've done is drawn this beautiful little plane up here, and pilots have an altimeter in their plane, and it measures the distance above the perpendicular distance above the ground. So it's always going to be perpendicular. And so even when we're over here, and you see that this is an obtuse triangle, so it opens up over here, don't draw your altitude or your height of the triangle over here. It's got to come straight down. It has to be perpendicular to the ground. So altitude is a perpendicular segment from a vertex to the opposite side. And notice that in this case, when you have an obtuse triangle, you have to have an auxiliary line. So you have to draw this auxiliary line out from this side to know where to come down, how far to bring your altitude down. So with obtuse triangle, your altitude is actually going to be outside of your triangle. Now, it seems kind of crazy, but it is true that here again, these altitudes do have a point of concurrence, and that is called the Ortho Center. Ortho, how are we going to remember this? Ortho means straight. When you go to the orthodontist, when you go to the orthodontist for him or her to do their orthodontics, what do they do to your teeth? They straighten your teeth. So ortho comes from a root that means straight. So your ortho center is the point of concurrence of altitudes, and altitudes go straight up and down. It is the perpendicular distance to the opposite side. So when you have your an acute triangle, your orthocenter is going to be inside of the triangle. When you have a right triangle, your orthocenter will always be on this right angle vertex here, because this is your height coming on this side. If you use this as the base, and then over here, if you were to use this as the base, this side would be your height or your altitude. Okay, so it'll always be, your ortho center will always be on the vertex. When you have a obtuse triangle, so what I've done is made this triangle a bit bolder so it's clearer to see, and your ortho center actually is going to be outside of the triangle. Okay, so the last part for you is for these. I know the numbers don't match, but just work with me here. For each one of these, BD, segment BD, tell me whether it is a perpendicular bisector, or is it a median, or is it an altitude. So for each of these, tell me for this one, is it which one of these three is it, and do that for each of those guys based on the information that you have here. There we go. We are done, and hope that was useful to you, and hope you have a good evening.